Okay. So, well, this is an re-recording of the communication, the protocols which you have in your syllabus, right? So, before that, let me go to your syllabus and show you what exactly you need to learn on this specific communication protocols, right? So, let me open this and let me share the content. Okay. So here, okay, just sitting there. Okay. So in your the syllabus, so you have to learn three important the communication protocols. One is MQTT, right? Other one is CoAP, and the one important that is HTTP. Even though that is not widely uh, used in terms of IoT building management system, but in other terms, the you know. The HTTP is very, very important. And also when it comes to the IoT and the building management system, right? So MQTT and COE are very much used. Okay. And then what we will be learning is by using these communication protocols, how we can able to integrate this IoT device to the cloud platform. So this is what the syllabus talks about, right? Okay. So let me share the other screen. Here we go. Okay. So this is the presentation. Let's start with this MQTT one. Okay. Now, what is MQTT? So MQTT stands for Message Queuing Telemetry Transport. And why it is very much important, because it is in very lightweight. Okay, one thing. And this is very much widely used wherever we need to implement the IoT and the building management system, right? So in that specific, use cases, this is very much important. Okay, that is one thing. Now, and the communication protocols, why it is widely used? Because it uses the low bandwidth. Okay, so why? Because the MQTT always uses the low overheads in the packet. Okay, when you compare with the other protocols, that CoAP, even CoAP is very much less, and the HTTP, when it compared to the HTTP, the specific protocol always carries the less overheads. That is the thing; it requires less bandwidth. Okay, and high latency. Sometimes so wherever we have very high latency in the system, right? So in that case, we cannot able to utilize the HTTP. Okay. And HTTP may, because this HTTP will be having the bigger, the payloads and the bigger, the data packets, so on, right, in the HTTP. So in that case, we cannot use that when we have the higher latency network and unreliable networks. Okay, so basically these these use cases, that is low bandwidth, high latency, and unreliable network. So most of the time, it is suitable for the IoT scenarios, right? So the IoT devices will be usually installed in the field level or else in the floor level, and sometimes this proper network may not be reaching these IoT devices, right? Due to the network not able to reach these IoT devices. Because of that, the reliable network is not available for this. Okay, in that case, we may have to choose the MQTT protocol. Okay, this is one thing. And the second use case, where exactly we will be using. So coming to the, the power smart grids, okay, industrial automation and the telemetry systems. Okay, so these are all the very widely adopted the use cases or scenarios. Okay, this is all about the introduction to the MQTT. Okay, next jump. Let's jump into the architecture part. Let's understand why exactly the MQTT is very much used, right? Now, I was mentioning earlier, right? So in this, the HTTP request, okay? So the constraint when we are using the HTTP is the latency, right? And the overheads. So that is what I was talking about, correct? And because of this, if we have the lesser the bandwidth, right, we cannot be able to use reliably the HTTP one. Okay, and also if you see, the HTTP device operates on the limited power also, right? So the device will be the smaller one if we are utilizing the battery powered IoT device, right? So if we are utilizing the the overhead the high overhead the protocols, then these battery operated IoT device needs to process those, right? And because of that, it may consume more power and the battery life will go down in the IoT devices, right? That is also one case. And to reduce that, again, we have to use the MQTT one. Okay, we'll see how exactly MQTT architecture works, but to understand why exactly we are choosing this, understand these constraints. Okay, and then coming to this MQTT part, right? You see, this is a very higher efficiency. The packets which is having the lower overhead compared to the HTTP. Okay, HTTP is having the higher overheads, right? And so this will operate over the TCP/IP model again, and the default the ports, right? 1883, the standard one. Okay, or if we are doing then encryption, that is, if we are using an transport layer security or SSL to secure the connection, right, from the client to host, in that case, the port will be 8883. Okay, this is one. And coming to the the reliable the delivery, so it relies on the asynchronous delivery, right? Okay. Now, yeah. So now let's understand the how architecture of the MQTT works. Okay. So MQTT always, works on this principle: publisher and the subscriber model. Okay. So the publisher never talks directly to the subscribers. Okay. And when we are utilizing MQTT, right? So we need the middleman because the publisher will never talk to the subscriber directly, right? And we have the middleman, that is the broker one. Okay, so we call this as a broker. And what is the significance of this, the broker one? Okay, so the publisher needs to only send the data once to the broker, and the broker can able to send the data to multiple subscribers. If we have a subscriber 1, subscriber 2, subscriber 3, and subscriber 4, and so on. So, right? So this is the good part about this. Let's see, right? If we don't have the broker, then this publisher has to send the data to all the subscribers, right? You think like, the bandwidth requirement, the processing and everything, it's doubles down, right? So to avoid that, the architecture is based on the publisher and subscriber, and the broker, what we will be using is to help the subscriber to get the data. Okay, that is what it is saying. The producers and the consumers are completely decoupled. So it is not coupled. Okay, all the messages passes through the central broker. So once the publishers, that is producers, will be publishing the message. Let's say this is an IoT, and just to take an analysis, I am using a camera, and camera detects the motion sensor, and it is sending the data to the subscriber. Wants to send the data to the subscriber. Before sending that data, these data will be stored in the broker. Okay, from the broker, multiple subscriber will be fetching the details, the camera details. Okay, and this subscriber, they will not be knowing who. Not subscriber. The publisher will not be knowing who the subscribers are and what the data is going to that subscriber. Everything will be taken care by broker. Okay, broker will have the complete information about the subscriber. Okay, and this is helps in isolating, that is decoupling the publisher and the subscriber. Okay, and coming to the MQTT clients, right? So we have importantly like the IoT sensors and smart meters, mobile applications. Okay, and so on. Right? These could be an example of the client. Okay, that is the publishers. And coming to the subscriber, just to give an example, what could be the subscriber? So it could be like the cloud. Okay, cloud dashboard, any analytical tools. So that need these the datas. Okay, and so on. Right? Okay, this is the example for the subscribers. It could be anything, any software running on a server which needs to process these data, right? So those data will be sent from the broker to the subscribers, right? Okay. Now, so let's understand the broker part. Okay. So let's see how the broker works. So now the broker is a central server, okay, which is responsible for managing the message exchange between the clients. Okay, so coming to the responsibility, what are the responsibility? The first one, the topic filtering layer. So it will be having the feature called topic filtering. So it will filter the topic, filter the message by the topics. Okay. Again, let's take an example. So IoT might be sending the different information to the broker, right? It could be on temperature, it could be on motion sensor, it could be on the current, voltage, or vibration, and so on, right? So these the broker will be filtering out all these topics, and only required topics will be sent to the subscriber. Okay, not all the topic will be sent, only the required, the messages will be sent to the subscribers. Okay, subscriber, as I said before, it could be in cloud also, cloud for the analytical purpose. That is first function. And the second function is like the routing and dispatch. So the as I said before, the subscriber is in cloud, right? So from the on-premises where my the IoT devices are there, that has to be routed to the cloud. How it will be doing is, so MQTT broker, it will be helping us to route to an active subscriber. It will have all the routing details, capability, and so on, right? So what it will be doing is, it will route the details, okay, to the respective subscriber. So that is second feature. Okay, coming to the third feature, that is authentication and security module. Okay, this is very important one, because not everyone can able to send the details to the broker. Okay, only selected IoTs can able to send it. It is again The IoT simply cannot send the message. First, it has to authenticate itself, because so IoTs are the weak link in any of the network, because the not most of the IoTs will be in latest technology one, and it may not be having the good security features enabled in that, right? So it is very much easier for the hacker to log into the system through the IoT device. So for that, what we have to do is, before we receiving any of the information from the IoT, we have to get the authentication, right? So IoT has to authenticate itself either by producing this CA, that is the certificate which is installed on this device. Once it is authenticated, then only it can able to send the data. Okay. Now, so this is one of the key feature or functionality of the MQTT. It will take care of this authentication. Okay, that is one thing. And coming to the fourth feature of this, fourth functionality, that is session persistence and state. Okay, so when I say the session persistence, that is like the IoT device, once it has been authenticated and session has been established from the IoT to the broker, right? So the broker is responsible to keep this session open, okay? So that the IoT device can easily send the data to the broker, and so the broker can take the further action. So the keeping the session open, it is what the one of the key functionality of the MQTT broker. Okay, the maintaining the session state. That is one thing, right? Yeah. So these are all the three key functionality of the MQTT broker, right? Coming to the broker examples. So we have a different broker. We can able to use it. So most commonly used one is Mosquito. Okay, this is one of the the lightweight open source edge broker. Okay, so when I say edge broker, this will be a very small piece of software that will be installed in any of the small server within the network, or else, so if required, we can able to also install on the IoT device itself. Okay, because it is a very lightweight and the open source one, right? And if you want to achieve this use case, the IoT device that needs to have the proper RAM and storage and the proper the processing CPU, right? So we have to be ensure that if we are opting for this small lightweight and installing that in any of the smart device, right, that has to have the adequate the resources available to process the data. Okay, that is one thing. And the second one is a Hive EMQ. This is the enterprise grade. This is like widely adopted by the enterprise. Okay, and so this is the specialty of this is the high availability. Okay, so sometimes when we are installing anything in an enterprise scale, right, always we have to worry about the fail safe, right? If we are only running on a one single main broker, what if that goes down? Complete system will be goes down, right? So to avoid that, we always needs to have the high availability. That is, if one broker goes down, the primary one, the secondary one should take care of the necessary the communication between the publisher and the subscriber, right? So the Hive MQ is one of that. So it by default gives the high availability so that the operation will continue. It will not be stopped, even though if the primary MQTT broker goes down, right? This is one important thing. And other one is EMQX. Okay, this is other broker. So this is highly scalable broker for a massive concurrent session, right? So when I say highly scalable broker, okay, what if I have millions of IoT devices, thousands, right? So those devices might be sending the data continuously, and they are configured in the such a way that every minute or every certain seconds it needs to be sent the data to the MQTT broker. From through that it has to be go to the subscriber. Okay, and this will be a continuous process, right? And the concurrency of the connection needs to be the maintained. So how do you handle this high capacity of the traffic? So one important the broker we can able to select for an high scalable system like this is EMQT. Okay, so whenever we have this large number of highly scalable and massive the concurrent connections, right, we have to use the MQTT one. Okay, and the last one, this is what we already used earlier in one of our examples, right, in the model number 3, if you remember, the AWS IoT. In the module number 3, so when we were doing the lab, correct, IoT based lab, initially, so the IoT data was coming from the device, and we were using the IoT core to get these data, correct? So this is one of the broker especially designed for the AWS. Okay, and this is fully managed and the cloud native broker, and this will help us to have different subscribers. If you remember, so when we were configuring this IoT, right, so as a subscriber we configured the S3 bucket, and then also we configured Kinesis, and so and so the multiple subscriber is what we had configured, correct? Right. So whenever we our use case demands the cloud integration, especially on the AWS, right, we have to choose the AWS IoT core. That is one thing, right? Okay. So moving on to the next. What are the endpoints? Let's see the endpoints on. Okay. Just to give you an example. So endpoints are the data generators. Okay. What are usually the IoT devices we will be using in the building, right? One is temperature sensor. Other one is power meter. If we have the solar, then solar inverters and smart thermostats. Like if you have visited any smart building or any of the, the latest innovative, the buildings, right? They will be having all these, the smart devices installed. Okay. What they will be doing is, so they will keep on logging the parameters in their memory, and then they will send back to the broker, right? Okay, and coming to just to give you an example, how it will be. So usually, even though so basically, what I'm trying to say is this data will be this machine will be sending the data in the JSON format. Okay, so again, JSON format will be an key pair value. Okay, voltage 230, and this is the key. This is the pair. Okay, so one, it will carry the attribute, other one will be an value. Okay, and it could be in current, it could be some temperature. So this format is known as JSON format. Okay, most of the cases the IoTs always generate the data in the JSON format. Okay, so this is one of the example. And coming to the subscriber part, okay, you see here we have a different subscribers. So that those are like the data consumers. Okay, what are the data consumers we will be having here? We have the energy monitoring dashboard. That could be a standalone software which we will be installing in one of the server. It could be an on-premises or the cloud. Okay, and the second example could be the cloud analytical platform. Here in our use case, we highly relying on the AWS for our lab, correct? So it could be an AWS, the cloud analytical platform, like QuickSight or as the SageMaker, so on. And it could be an Bedrock also, right? That is one thing. And the third example could be in SCADA system. Okay, even the SCADA system, sometimes they might require these parameters for the internal processing. And also it could be an the mobile. Okay, it could be an mobile also, right? Mobile application. Okay, so these are all the example of our subscribers. Okay. Okay, and the subscriber job, their job is to register the interest in specific topic and receive the push updates. Okay, that is what I was explaining. The job of this data consumers is to receive the data, and then either that will be forwarded to the necessary the processing application, or it will by itself, it can able to process it. Okay, those are all the publishers and the subscriber. Okay. Okay, and another one note is there. Okay, so MQTT client, like an Edge gateway, can act as a both subscriber and the publisher simultaneously. Okay, that is one point we have to note down. Okay, now coming to the topics. So I was mentioning about the topics, correct? So MQTT uses the topics to route the table. Okay, how the topics will be? So topics are in a hierarchical strings used to organize the messages. Let's take an example. Here, if you see, we have the different folders, correct? In the energy, we have the building. In the building, we have the flows, and we have the different meters. So, for example, if you want to specifically monitor this specific meter in the floor number 2, meter 1, the broker can only filter out these data that which we need, that is second floor first meter. That is that means the broker can able to target specific details or the data, so that we don't have to fetch the other details which is not necessary. And if you are fetching that data unnecessarily, we are wasting our resource, and also we are wasting the bandwidth and the processing power, right? So for that reason, we are not selecting completely. We are just filtering or else specifying what exactly the data we need, right? That is one thing. And if we want to completely monitor all these things, right, in the building, then we can able to directly use the wildcard. When we use this means, so the broker will be accepting all the data which is coming out of the building 1, irrespective of floors or irrespective of the meter IDs, right? That will receive all the data, all the meter data in the building 1. Okay, this is how the topics are generated, and these topics will be registered to our MQTT broker. Okay, I hope this is clear. Now let's talk about the life cycle of the message, right? So this is very much important when we are talking about this the important communication protocols, right? So we need to know the life cycle of the message, right? Now let's understand. This is an IoT device. Okay. Now that is sending the data. First, initially in the step 1, what it will be doing is the device connects to the broker using the TCP. Okay. Why the TCP port? That is what it is saying. The step 1, connecting the device via TCP to the broker. Okay. So that is the first step. The connection will establish, and when the connection establishes, the IoT has to authenticate itself by producing some, the CA, and then once it is authenticated, the broker sends back the acknowledgement back to the IoT device, telling that yes, you have been authenticated and you are good to do the communication. Okay, that is one thing, right? Now, after this, in the second step, if you see the second step, right, it is all about subscription. Subscriber register the topic which is actually required. So this subscriber, they will register. It could be on multiple subscribers, right? I said it could be on the cloud subscriber. It could be an on-prem analytics, and so on. Okay. Now, so that is the second step. So in the second step, again, subscriber will talk to the broker, and the broker, once it has to authenticate. It cannot give the data to any of the subscriber which will be trying to reach out to the broker, right? It has to authenticate, and it should have the privilege to accept the data. Okay. After everything, after seeing it has been authenticated, then the acknowledgement will be sent back to the cloud subscriber, or else it could be any other analytical tool, correct? The subscribers. Okay. So that is how the step 2 will be, subscribing and the acknowledgement. Okay. And just to give you an example, in the previously we saw that, right? The building details. So here the subscriber wants to have the building details, all the meter details, right? Building meter details. So this is one of the topic, and they will subscribe to this topic, and they will get, the subscriber will get all the building meter details here. Okay. That is the step number 2. After that, in the step number 3, it is all about the publishing the message. So publisher send the message to the broker. Okay. In the step number 3, the publisher will be sending the data to the broker. Okay. Let's say how exactly it will be sending in the JSON. JSON only. Okay. JSON format. Let me rub that just a minute. Okay. So JSON format. And what exactly it will be sending? It will send the meter ID and the power consumption. So and so that will be stored. This data will be stored in the broker. Okay. And also along with this, it has to send the timestamp, because without this timestamp, when we do the analytics, right, it will not be that effective, or it may not be able to process this data without the timestamp. That is the thing. It has to give the timestamp details. Okay. So coming to the last part, that is the 4th step. So distribution again. So the broker will distribute the data to the respective subscribers. Okay. It could be multiple subscribers, right? Okay. Now let's talk about other key feature on this. Okay. And in the MQTT, we can able to configure 3 important features. One is the quality of service 0, quality of service 1, quality of service 2. Okay, what exactly these are? So these are the the quality of service what we will be defining in the MQTT broker. So how fast it has to be delivering, or like how frequently or how efficiently, and so this is regarding the service part. Okay, in the quality of service 0, it is like fire and forget. So no delivery confirmation is sent back to the MQTT. Okay. So it is like if we wants to have a faster telemetry, that needs to be delivered. Okay. And so the objective here is to send the data within a very low latency at a very high speed, correct? So if we have that kind of use case, this is the best. So even though if the packet drops in the middle, it doesn't matter. So it is not suitable for the mission critical, the data transfer, right? In that case, this is not the the quality of service we need to select. It is like at least once deliver, and then that's it. We don't get an acknowledgement whether the subscriber are received this data or not. We will be not worrying about those part. Correct. And coming to the second one, that is QoS 1. At least once deliver. At most one is QoS, and at least once is like QoS 1. So what it will be doing is the broker replace with an PU back, this one. It is like publisher acknowledgement. Okay, we have the publisher and the subscriber, right? So PU back like then publisher acknowledgement. So it expect the subscriber to send back the acknowledgement telling that it has received the message. Okay, that ensures the delivery of the required information has been completed. Okay, this doesn't mean like it is like efficient one. Sometimes there might be the duplication also it can occur, and still acknowledgement will be sent back to this specific this broker telling that the communication has been established and the packet has been successfully reached to the subscriber. Okay, but so this is actually the best for the IoT monitoring and so on. So, and also the cheaper compared to the other QoS, because it needs lesser the bandwidth and lesser the processing of the data. Okay, and the third one, that is the QoS 2. So exactly once, that is it rely on the 4-step handshake. Okay, so initially there will be a couple of the handshake which will be happening between the broker and the subscriber. Okay, once the handshake, that is the communication is established, that is acknowledging each other and sending the data, then again sending back the acknowledgement about the receiving the data from the subscriber and so on. Once it is done, and here two things will happen. There will be no lost messages. Okay, and also there will be no duplication, right? This is one thing. So this is when we wants to achieve this QoS 2, right? This required very the high level of the configuration. Okay, and this is required when we have the mission critical, that is building or vaults values and so on, right? In that case, this is very much needed, QoS 2. This will make sure that the message is actually delivered once and not the information is lost behind. Okay, now coming to the packet level information. Okay, if you see the packets, okay, it has the fixed header, it has a variable header, and also it has the payload. Okay, in the fixed header, what this will be doing is it's always present and contains message type like the QoS level and DOP flag, the remaining length, and so on. Okay, so this is fixed. It will give the certain information about the quality of services, and so if we are doing any flags within the messages while sending the data in the communication protocol, right? So in that case, some flags it will be having, and what it also gives the information about how much length it is carrying, the packet length. So that is all about the fixed header. Now coming to the variable header. So what exactly this will be contain? It contains the publishing message, the published message containing the topic name and the topic identifier. Okay, so this variable header can have the information like, so the topic names, like we had taken one example previously, right? We have the building, and within the building we have the different floors, and different floors will be having the multiple meters, right? So this meter data will be, these topic names will be embedded in this, and the packet will be moved to the MQTT. Okay, and the payload will actually have the actual information about you know the IoT which is sending the data. So IoT sending the data, what exactly data? Everything data is will be mentioned in the payload. Payload carries the actual information. Okay. Yeah. So this is another important topic. Why? Because the security, even though if you consider any of the communication protocol or any of other protocols, right? The one major important layer comes is the security layer. Okay. So again, so the concept is TLS, right? So if we are doing the communication from the publisher to the MQTT or just in plain the connection, so it is not secure, right? Anybody having any access can able to directly log into the system, and or else any bad actor who has the good infrastructure can able to snoop the packets, and he can able to easily decode what exactly the packet carrying. It could be an IoT information or like server details and so on, right? So it is easier for an attacker to spoof the packet. Okay, how do we save this? So the one important thing is we can able to use the TLS, that is transport layer security, while transmitting the data from the producer to the MQTT, right, or else MQTT to the cloud. We need to encrypt this connection. Okay, so whenever we have the secured connection from these two the points, right? Even though the attacker, like hacker, tries to get these packets out, he may not be able to see what exactly the information inside that packet. Okay, so that is where like we need to have the encryption. Okay, and this the port, as I said earlier, right? So when we are using this TLS, it will be 8883 port. Okay, and coming to the authentication mechanism, so this MQTT supports user and password. This is one of the weakest authentication mechanism when it compares to the latest authentication technique, right? So even though it is the weakest, but still this specific communication protocol will be supporting this user and password. And coming to the other type of security, that is X501, okay, .501 certificates, that is CA certificate. So usually we will be installing these certificates in the IoT devices, and then when IoT device will be start communicating, right? So it has to produce that certificate, and then only it will be authenticated. Okay, and other way of doing is the token based authentication. So we have to generate the token, then token will act as a password for us, API tokens. Okay, and then we have the OAuth. That is all of the the way of authenticating it, right? Okay, and the third part, if you see the access control, right? So why exactly the access control is needed? Even though the IoT devices or the subscriber can authenticate themselves and they can able to get the data, but so we need to have the granular topic level authorization. Let's take, if subscriber 1 has to have the information only on the floor number 1, okay, and he should not have the information about floor number 2. So these kind of granular level of the authentication, the access control, we can able to achieve by using this access control. Okay, this is how we can able to reduce the attack surfaces. Okay, even though if subscriber 1 is compromised, it will be having only the floor number 1 details only. So it will not be carrying the other details. So we are not unnecessarily giving the data to all the different subscriber. We are only giving the authentic, we are just allowing the specific subscriber to subscribe to the specific topic only, not the all the topic. That is what it means. Okay. Again, this is simple. This is the real world scenario where we have the sensors, correct? So this is what the example I was providing earlier. So we will be having the sensors and edge gateway. So edge gateway can be an router. So this sensor, this is an field device. Field device. Right? So this device will be sending the data to the router, because without the router we cannot transfer the data to the respective the broker. Here the cloud MQTT broker we are choosing is the cloud one. Okay, it could be an AWS IoT, right? So this the cloud, the broker will be having the subscribers like S3 storage, that is the storage part, and this DynamoDB is for the JSON. And it could be another AI and ML analytical engines. It could be other web-based application for the dashboard. So this is the real world scenario. Okay. This is one thing. This is just to give you a very high level how the sensor will be connecting to the cloud and then how the data will be processed. Okay. Now, again, another example. So this is specific. Okay. The previous one was very generic one, correct? So this is specific. So here we are trying to monitor the power consumption, okay, across the multiple floor of a specific commercial building, and everything has to be done in the real time, not the static data which will be sent. It has to be in the real time. Okay, how do we do that? So here, all the details, IoT details, smart device will be sending, right? So these devices will be aggregated, okay, in the edge gateway, and then we will be establishing an MQTT communication to the broker. Here, the broker we have selected is a cloud one. If we have any, server within the on-premises, we can able to install that here in the on-premises. For this example, we are using the cloud-based broker, okay? And then this broker is sending the data to the monitoring and the PostgreSQL, and then the data, so the process data, if we want to take certain actions, the actions would be sent back to the IoT devices, okay? So this is, this is not only the one-way communication, it will be a bidirectional one. So the broker can send the data to both the ways. Okay, so that IoT device, even IoT device will get the information, and the subscriber also will get the information to and fro. Okay. Okay, this is what I was giving an example. So how it looks, the JSON file, right? We are sending the certain details, and in the subscriber, we will get the output. Okay. And so we can able to use the Python language for this, okay? And we have to import certain libraries, MQTT libraries, okay? And we can do the the connection that is called as software-defined kit SDKs, okay? Before that, we have to do the Boto3. This is AWS. If you are planning to connect to the AWS, right? This needs to be installed as a library. Okay. Now let's talk about the strengths and the limitations one. Okay. Coming to the strengths, so it requires very extremely low bandwidth, one, And the second, the point is it is event driven. If certain the event is happening, then only it will be the communication will be triggered. We can able to configure in that way also, right? Highly tolerant of unusable network, unstable. I'm sorry, unstable network. Okay, so even though the system is not, the network is not that great, even that conditions, this specific MQTT protocol will be able to establish the communication and send the data from the IoT to the broker. Okay, and yes, we can able to use the millions of devices. And this is example we saw it earlier, right? Okay, different type of MQTT, where how much they can able to they use uh, the connection, the concurrent connections, and it can able to scale up to the millions of devices. Okay, coming to the limitations, so inherits the TCP. Even though this is it makes the system reliable, but still it will be having overhead, because TCP will have little overhead compared to the UDP the protocols, right? That is the reason. Okay, and also it has the strict limitation on the message size. We cannot send the larger message is in this MQTT. That is what, this is unsuitable for the larger file transfer. Okay, sometimes what will happen is, if we are using only one MQTT broker, if that goes down, complete system will goes down. So that is one thing. So this introduces a single point of failure. So the best recommendation is to not to have the single MQTT. We need to have the cluster. Okay, when we have the cluster, even though one fails, other one will take care. Okay, these are all the strength and limitation. Okay, yeah. Now let's move to the other one, that is the next HTTP. Okay, this is very much important protocol. Okay, so we need to study three protocols, right? The first one what we saw was MQTT, and now we are looking at the HTTP. So I will just take 5 minutes break. Okay. Okay, so let's continue with the HTTP protocol. Fine. Now, so in this specific, the module, we'll talk about HTTP protocol, its architecture, and how this communication protocol can be used in the IoTs. Okay. Now, coming to the fundamental part, the foundation of this distributed communication, that is like, you might have heard or might be using this HTTP directly or indirectly, right? So whenever you open any browser, so in the background, so it will be using the HTTP one. Okay. So usually whenever we want to reach some website, so that is www dot something, right? So the data, the request, whatever we are requesting certain information from the server, right? That request go in the form of HTTP. Okay. And then the server will reply to us, right? So HTTP stand for Hypertext Transfer Protocol. Okay. And this operates at the application layer. Okay. And this is this communication widely used in the distributed systems, right? And let's take an example of web browser, web servers, the IoT devices, and the cloud platforms. So whenever we want to establish the connection between these, then yes, we will be using the HTTP protocol. Okay. So this HTTP is widely used in the REST. Okay, the APIs. API is an application programming interface. Whenever the information that needs to be sent and that needs to be get back, right? Usually we use the API. So REST is one of the API. Okay, we will understand in the next couple of the slide what exactly these the REST APIs are. Okay, so this is one thing, and this is like the client and server model. So if you see here, the client and the server, the client could be a mobile application or the laptop browser, and the server could be in the database server, the application server, and the web server. Okay, and this specific HTTP operates on the TCP/IP model, and there is two kinds. One is HTTP that operates on the port number 80. Okay, and the HTTP works on the port number 443 for the HTTPS. Here we are using the transport layer security and SSL for the encryption. Okay, for that reason, whatever the communication we use at in daily life, or like it could be any communication, it has to be encrypted. And if you want to check in your browser, you can able to check whatever the connection you have been doing. The most of the cases, it will be an secured one. HTTP, yes. Okay, and now we have in different the version of HTTP we have. One is HTTP 1.1, HTTP 2. The latest one is HTTP 3, right? And I was mentioning about the ports. What exactly these ports are? If you see the HTTP 80, HTTP 443, you might be wondering what exactly these ports are. So usually in the computer will be having certain defined the ports 0 to 650. Sorry, not 650. It's 65,000. Some odd numbers will be there. Okay, up to that, the number of ports we can able to utilize for the communication without opening any port in any of the client or the server. There will be no active communication that will be established. Okay, so there is two kinds of the ports. Okay, so one is the well-known ports, that is 0 to 1023. Okay, the range is known as the well-known ports. Okay, and these ports are maintained by so you might have heard about IANA, right? So this is Internet Assigned Number Authority. So this organization is responsible to manage the ports. Okay, Now, so these ports act as a listener, right? It has to be, we have to open to get the data. That is one thing. And to give you an example of well-known ports, you might have heard about, the FTP, right? That is file transfer protocol. Either it will be running on 21 or 20, okay? And 22, it is an SSH secured shell for the connecting to any of the server remotely in a secured manner, right? So we use SSH, okay? And we have other one, the port number 25, that is for the SMTP, okay? So simple mail transfer protocol, right? And yes, 80 and 443 is for HTTP, and other one is 445, that is for the Microsoft file services. Okay, so there are a lot of other the ports, well-known ports. These are all usually day-to-day activities. You might have heard about these ports, right? Okay, that is one thing. And now, apart from this, the range of other ranges are after 1,000, and also there is other range after 49,000, right, up to 65,000, nearly 65,001, right? So those are all like an ephemeral port that is not dedicated to any of the specific the protocols. Okay, we can able to use as in temporary. You can able to open it or the close it. Okay, at required sessions. Okay, you need to understand what exactly these ports are, right? Okay, so moving back to the architecture, right? So in the previously also in the various sessions we discussed about this OSI model. So this is how the OSI model will look. Okay, so this will be having the 7 layers usually. First layer, second layer, third layer, and this is an application layer, which will be, there is one other layer that is physical layer usually. So let me redraw this. Okay, this is an TCP model. So let me explain the iOS model for the better understanding. Okay, so it not iOS, it is OSI model. Sorry. Okay. Usually what will be having physical layer, that is called layer number 1. Usually we have the cables, fiber. So that is called physical layer. Then we will have the data link. So that we have the Ethernet. Also have the Wi-Fi. It is like data frames we are having. After that, we have the network layer. Here, it's all about the internet protocol, IPs. So here we have the packets. Data is converted as in packets. Okay. After that, we have the transport layer. That is 4th layer, right? This is 3rd layer, 2nd layer. This is 1st layer. This is 4th layer. Here, it's all about TCP, UDP. Right? TCP is a secured one, and UDP is the faster way, but it's not that. Not secure. So this is a reliable one, TCP, and UDP is not that reliable, but it is faster one. Okay. Now again, the transport layer, it is on 4th layer. Then we will be having presentation, application, the presentation, and session. Presentation. So this contains layer 7, layer 6, layer 5. Okay. Usually now combination of this is called as iOS, and it is very much important that everybody knows about this basic networking the layers. Okay, this will be an fundamental knowledge for any of the communication, the protocols what we will be studying, or when it comes to the networking and the communication, right? This is the basic knowledge what we need to have. So coming back to this, so here you can able to see again we are trying to, the protocol stacks, the HTTP in the protocol stack. Here this is where we are using this HTTP in the application layer, okay, where the data is sent and requested in terms of request and the response. We'll see how exactly this will be happening in the further slides. Okay, so I hope this OSI model and these specific network layers are clear. Okay. Now coming to this HTTP, right? So the beauty of this HTTP is it is an stateless. Okay. So when I say stateless, every connection which is happening from the client to the server, it will happen only once. Okay. So client or like server, it will never don't remember the connection after the once that request and the response happens, right? So it is not persistent one, so it is stateless. So uh, you know so this is every time the client wants to connect to the server, again it has to establish the connection. That is what I mean to say. Okay, that is what it is saying in this specific slide. The HTTP interactions are inherently stateless. Okay, each communication cycle is independent, okay, and retains no memory of the previous request. So that is what I was telling. It is not the persistent connection, so it will be in stateless. Okay, and how in the step number one, what will happen is the client opens an TCP connection to the server. So whenever the client, the laptop, let's assume, or IoT device, right, wants to communicate to the server, right? So first thing what it will be doing is, so it will opens the TCP connection to the server. Okay. And then in the second, so the client, that is, this sends send an HTTP request to the server, telling that certain information is needed. So that will be a request that will be sent to the server. So server request, once the request is processed in the server, okay, so server sends back the required information. Okay, so this is called as request, this is called as response. Okay, and there will be authentication will happen before actual the communication starts and sending the data, right? So that is not shown here, but in the real world scenario, before the connection, the client has to authenticate itself, and then only the server will send the required details. Okay, after this sending and receiving of the data, that is request and the response, so the connection is lost. Okay, that is the thing. So HTTP, it is an stateless, so it is not the persistent one. So the flow, the client requests the HTTP to the server and server responds to the client. Okay, that is what the flow is. Okay, so let's understand a little bit deeper how exactly the HTTP request works. Okay, right, see this request one. Now if you see this method, okay, this is the method, the type of operation. Now I am using HTTP 1.1 for our connection, right? And also we have to give the host URL, I mean the resource location URL. Okay, that is this, and the agent, the Mozilla, it could be in the Chrome or else Edge, so on. And coming to the that is, I was explaining about the header, right? So this header will have the metadata. Okay, so what the metadata will be having, the host address, and what kind of user agents, that is Mozilla or something, and what exactly it accepts, the application that is in the JSON. Content type, it could be in JSON, and the length of that, it is 120. Okay, this is the example, the header, what the HTTP request will be sending. Okay, and coming to the actual body, in the actual body, so this containing the device ID and the temperature details. So these details will be sent as a request. It could be sending these details to the server, telling that to save that data, or else and to update the data to certain records and so on. So there are like different request methods are there. We'll see in the next slide. Okay, so for now you just understand this is how it will be. So initially there will be a method and the URL of the resource location, and we will be sending the metadata in the headers, and then we use the body to send the actual data in the JSON format. Okay, that is one thing. This is all about the request. The client is sending a request to the server. Now let's see how the server responds to this. Okay, and coming to the server response, right? So server will have the different type of status code. Okay, the 200 is one of the status code. When we say 200, it is the success code. Okay, so again I will be going in the little depth in the next 2 or 3 slides, and I will explain the different type of the the codes, HTTP codes, right, for the debugging and to understand what exactly it is, whether the response will come or not, what is the error, so and so. During that the debug operations, we may need the response codes. Okay, that is the status code. Okay, it is telling yes, 200 is the success, telling that the server has received the request and it will process the data. Okay, the content type again of the application, that is JSON, and the content length, this is again header, it is going back, okay, to the client. What are the body, in the body, what are the details? We are sending the status, that is success, the message is data received. Okay, this is what the information it will be added in the body. Okay, now, so I was talking about a different type of the request which will be sent from the client, right? So what are the different request, right? So one is the GET request. So in the GET request, the client will ask the server to give some information, that is to retrieve some data. Okay, that is one thing. So probably if we open any browser and if we type the Facebook or Instagram, right, we are asking the server to provide some information to us, right? That is called the GET information. Okay, and that is GET request. Okay, not information, GET request. And the second one is the POST. POST is like the client, the laptop is sending the data. Here it could be an IoT device also, right? So IoT device is sending the data to the server, okay, to update some value in the server. So that is called as the POST, send the data. And the third one is PUT. In the PUT, it is all about update the resource. So the server will be updating the resource internally, okay, based on the information what we will be sending in the body of the this HTTP, right? That is one thing. And the third one is the delete. So delete, yes, as name suggests, we are sending the request from the client to the our server to remove certain resources. Okay, so from the server, that is the delete option. And the patch, the partial update, if you want to do any partial update on the existing record, right? How do we do that? So we can able to send the patch request from the client in the HTTP body with an required update. So this will be taken care by server. Okay, as in, so having said that, so let's move to the sixth one, that is head. In the head, it retrieves a certain the value of the values from the our server. Only certain values, not the all the values. The top 5, top 10, those kind of values we will be getting when we use the head request. Okay. So these are all the important requests that we will be using. Okay. Again, coming to our important, the code I was talking about earlier, right? There are like certain the codes which HTTP will be using. The one thing is the success code. In the success code, so whenever you type something in the browser and you get some error, right? 404 error, 401, 404. So these kind of errors you will see in the browser. But when you are deploying any IoT, you may not be able to get it in the IoT itself. But if you go into the server and check what exactly happening in the logs, right, you will be getting these kind of uh, you know the codes, right? When you see 200 series, right? For example, if you see 200 as an code, that means whatever the request and the response, it was successful. And if you see 201, it is all about the created. It's created. So that is what. So basically 200 series is all about the success. Whatever the action, put, read, delete, and head. So those kind of requests what we'll be sending from the client, right? So that is the success message is what we'll get if we get the number 200. Okay. Now, if we are getting an 400 error, 400 series error, okay, even before that we have the 300 also. So when you get an error, 300 error, that means redirection. Okay, the further action is needed. Let's say 301 is like the page has been moved permanently and so on. So this is one of the code what we get if the redirection is happening. Okay. Now, coming to this the 400 series now. Okay. In the 400 series, it's all about the client error. Okay. It's all about client error. In the 400, it's the bad request. Okay. So the 400 request is all about the request which is sending from the client, which could be a bad request. Okay. Let's say 403 specifically, I have not mentioned here, but 404 is like the forbidden, and 429 is too many requests, and so on. So this is one, and the 401 is for the unauthorized. So if we are not authorized to view that specific page or retrieve that page to the IoT, right? So if we are not authorized, then 401 is the error code what we'll get it. Okay, and this is very much common when you type something in your web page, and if it is if the the web page is not able to find, then you will get 404 error. That is the it is not found error, right? And the third one is we have it is the fourth one, right? 200 series, 300, 400, and 500 series one. So here we have a 500. So this is all about the server side error. Okay, in the server side error, so it could be 501 and the not implemented, 503 service not available, and so on. So this is all about the server side errors. Okay, this is all about server side error. Okay, so this is specifically important when we want to understand the HTTP, the protocols, right? So these are all the fundamentals. So knowing the port knowing the port numbers, knowing the the get port and other request methods is important, and also these error codes, response codes, error codes. So these three is very much important when we want to learn something in terms of HTTP communication. Okay. Now, again, this is one of the important, uh, the concept. So it is all about the structuring system with REST. Okay, REST, stands for representational state transfer. Okay, so this is used on the over APIs, that is over the HTTP. Okay, so when we use this REST API, right? API is then the application programming interface. Okay, so that is used to connect between the client and the server, and to do active communication between these two, right? So the API will help to send the data and the receive the data. It will act as a middleman, right? It is just an analogy. Okay, now, so this REST API, it is the stateless communication. Okay, and this communication is also it will use the HTTP method. Okay, and this is strictly resource based URL. So how the REST will act as, we have to provide some URIs. Okay, let's say here you can able to see this specific examples, right? I want to get specific device details, that is fetches a list. If your API v1 device, if you are sending the put with an URIs, this is the URI, correct, to add a new device. Okay, and the get is the fetches a specific device. Here I have clearly specified the device name here, so the whatever information we'll get it is for the specific device, and this is for the to add the new device. Okay, that is how it is. That is the REST API. Now, how do we map this HTTP in our real-time example? So in the real-time example here, so we are trying to connect the IoT sensor, okay, to our cloud server. Initially, in the previous, the protocol, that is MQTT. Again, it is a similar setup, but there the architecture is different. Okay, there also we are trying to connect the IoT device to our cloud and do some analytics. In the similar fashion here, the IoT device will talk to our edge gateway, the router, and then these will establish a connection over the internet through the HTTP post, and the server will respond based on the request. Okay, so this is what the communication. So this is very high level, but this is how it works. And yeah, so again, this is another example similar to the IoT. Here I have mentioned the smart meters. Again, the smart meters, if we want to monitor the smart meters from the cloud, in that case, so the smart meter always talk to the IoT gateway, and the IoT gateway will establish the connection to the cloud REST APIs. Then these will talk to the database. From the database, we can able to pull the data to the analytics dashboard. Okay, so this is how the flow will be. Okay, again, the same thing I have given in the the code format. Okay, so here you see the device will be requesting, it is sending the post, and this is an URI. Okay, and where exactly it has to go, this is the address, and this is then the actual data, the meter ID, the voltage, the power, and the timestamp, and that will be sent over the internet. Okay, and then the server will respond back with an okay. If it is sending any other series of errors, then you need to understand what exactly the problem is. Okay. Now, coming to the advantage and disadvantage part, right? This is very much important to understand, like when to choose which communication protocol and what is the advantages over the other in the communication protocol. So first one is the advantages. So it is simple and widely supported. Okay. So HTTP are widely adopted in the industry. So that is one thing. And so, yeah. And this is the platform independent, irrespective of the platform, irrespective of OEMs, we can able to use this. Okay. And the natively it supports the REST API, which we already saw in the previous example, right? So this this helps us in utilizing the REST API, okay, so to establish the communication and fetch the details, okay, and easy of integration with the cloud services. And so most of the cloud, the integration will happen by using the HTTP, okay. So for that reason, as I said earlier, because of widely adoption of these technologies, we can able to use the HTTP. Okay. Now coming to the limitation part. Okay. This is one of the important one, because this the limitation is where we opt for another communication protocol like CoAP or less MQTT over this, especially in the IoT implementation or else in the our smart buildings. Okay. Why coming to the limitation, why this is not recommended? Because it has the high overhead due to the larger text headers. So as this is having the large header size, this is not preferred. It requires the larger or bigger bandwidth. Okay. And also it might need more the processing, right? One thing. And second limitation is it's a stateless, right? So I was mentioning earlier again. So this is not persistent session. Every time the device wants to connect, it has to establish a new connection, right? So this is the one of the drawback. So the number of connection, number of the transportation of the the packet to the server, it increases. Okay. And yes, the frequent connections reduces the energy efficiency, obviously, right? So if we have one connection already established, and we can able to utilize that connection to send the data or the received data. And when we have that setup, so it is all about the efficiency, right? So instead of every time we have to establish the the connection and then do the sending and receiving the data. So it is not that efficiency. Higher latency compared to the specialized protocol. Okay, even though this is one of the good protocol, but when it comes to the IoT and the building management system, right? So we prefer the other protocols over this HTTP. Okay, let's compare this with the MQTT and CoAP, right? So yeah, coming to the features, the communication model, that is HTTP works on the request and response, right? So request is put, get, that kind of request, and the response will be success, and it will the server will do the necessary action based on the request. One thing. And coming to the MQTT, it is all about the publish and subscriber model, where the IoT device will send the data to the broker, and broker will distribute the data to the subscriber. So that is the publishers and subscriber model. And coming to this CoAP, CoAP is also similar to the HTTP. Again, this is also on the request and the response. And coming to the transport, the both HTTP and the MQTT are working on the TCP. Only CoAP, the protocol, it is working on the UDP. Okay, and the UDP is faster, but it is not that reliable. Okay, and coming to the overhead part, so HTTP, as we discussed, right? So HTTP will have the higher overhead, and the MQTT is low. But when it compared with the CoAP, right? So CoAP is having very low overheads. So the CoAP is preferred the protocol for the IoT devices. Okay, and that is what in the last row it is telling the IoT suitability. That is the HTTP. It is moderate. We don't choose. If it is necessary only, we will choose the HTTP protocol. If not, we use either MQTT or else CoAP. CoAP is the excellent choice. Okay, even the MQTT. Yeah. And coming to the the protocols in the the security protocols, right? Again, this is here also we are doing the encryption by using the SSL, okay, and the TLS encryption. This is important again. So whatever the protocols what we will be running, we need to do the encryption part. Okay. So SSL means secure socket layer 1. Okay. This is a successor of the TLS, and where we are using the cryptographic the protocols. If you remember in the model number 3, we were discussing about what there were different type of keys, asymmetric and symmetric type of keys, where we can able to utilize those to encrypt our data to safeguard it, right? So same concept here. We are using our SSL or TSL to do the encryption. Okay, one thing. And again, in that encryption, we are using the certificate authority to generate the public and private keys. Okay. Now, so why do we need this encryption? So this is helps us in the to avoid the man in the middle attacks. Okay, and ensures the data whatever we have received it is integrated, and it has the confident. It's the data integrity and the confidentiality of the data which we are sending from the IoT device to the server. It remains the same, and it is intact. Okay, one thing. And the other way of doing is the authentication token. So the tokens. So tokens are digital credentials. So issued after an successful authentication. Okay, when IoT device successfully authenticate to the server, right? And then after that, there will be the token that will be issued, and this token will act as a password actually. Okay. So yeah, this is one thing, and other one is OAuth, right? So currently, the latest one is the OAuth 2.0. And so how this works is, this is an authentication frameworks. Okay, so that allows the application to access the resources on behalf of the users without sharing the credentials. Okay, you might be using it day to day life. Like for example, you will be using the Google as an sign in for a different the web pages, right? Instead of you creating that, or else you creating any account or sharing your password and user, instead of that, we will be using third party, that is the Google, as an authenticator, right? So same thing, the OAuth, it's an it's an one of the important security what we will be using. And other one is the API keys. And so this is an one simple string. Basically, it will be the random hash values. Okay. So this again, this will be acting as a password. Okay. So usually how it works is, so whenever we send a request, correct, in the header or the in the query parameters, we'll send this API keys. So API keys key is an the standard, the hash values with an alphanumerical string. Okay, and whenever we send this in the header, so in the server it will see, okay, this API keys belongs to our our devices, and it is safe to onboard or receive the data from this specific device. Okay, so the good advantage of this is, so it is easy to implement, okay, and good for identifying the application or the services, right? But the problem, coming to the limitations or the con, so it is like less secure than the token one. Okay, if leaked, they can be reused, and so on. So preferably we go with an the the token one. Okay, yeah. So this is all about our HTTP protocols. Okay, so now let's cover the last one, CoAP. Okay, let me close this. Okay, let me open this CoAP. Yeah, okay. And out of three protocols, this is the last protocol. Okay, yeah. So I will just take 5 minutes break. Okay, so let's continue with this another protocol, that is the CoAP one. Okay, so this specific protocol, so the constraint application protocol. So this is specifically used for the our IoT devices. Okay, for the just a minute. Yeah. Okay, for the IoT devices, right? So this specific, the protocol, the communication protocol has been developed and maintained in the RFC 7252. Okay. So if you are really interested into deep dive into this specific application, the constraint application protocol, you can able to directly download the files from the this specific reference, and you can able to deep dive in terms of the architecture. Okay. Now, coming to the comparison part. Okay. So, okay, so this is an application layer protocol, very lightweight. So we saw in the earlier the presentation and in the comparison also, right? So compared to the MQTT and the HTTP, right? This specific the protocol, it has very low pore rates. Okay, makes that as a very lightweight application layer protocol. So this is specifically designed for resource constrained devices, so that the low power network which are used to carry the IoT device informations, right? So in that specific use cases, we always go with this application protocol. Yeah, as I said before, so it was like standardized in the RFC 7252. Okay, and yeah, the coming to the the targets, it is a low power network and the resource constrained devices. It could be sensor, embedded controllers, smart meters, and the actuators. Okay, yeah. So if you see here the web stack that is running on a HTTP and the TCP, right? So it is a little bit heavier. So that is where this specific CoAP comes into picture, that works on the UDP. That is the it, even though it is not that much reliable compared to the TCP. Okay, and but it is faster. So whenever we have the resource constrained devices, right, and also low power networks, in that specific use case, this acts extremely well. Okay. Yeah. So this is the introduction to this the CoAP. Now let's talk about the architecture part. Okay, and coming to the architecture part, so the CoAP architecture follows the RESTful communication model. Okay, that is similar to the HTTP, which we saw last in the last session, last PPT, right? So the RESTful is an stateless one. Okay, so even though whenever IoT wants to communicate, every time it wants to communicate to the server, it has to establish the new connection. So this is the session, it is non-persistent one. Okay. So to address this, so we are dividing into the two V zones actually. Okay. In the zone 1, so it is all about the sensors, the actuator, the smart meters, basically the field devices, right? So they will be running on the CoAP server or the client. So what exactly these clients are? So these clients are this piece of software. Okay. They will be installed within the smart meters or the smart actuators and the sensors. Okay. So now this the clients, the small piece of software which is running on these devices, right? It will establish in connection to the IoT gateway via IP version 4 or IP version 6. Okay. So difference between the IP version 4 and 6 is IP version 4 is like the 4 octets. Okay, you might have seen that is like 192 192.168.1.1, or it could be anything. And the IP version 6, it isn't 32-bit, 128-bit. Okay, this is 32-bit IP version 4 and 128-bit. If you see the length, correct, it's in very hexadecimal notations is what we call. We have the billions of IP addresses what we will get when we implement the IP version 6. Okay, so why we are slowly moving towards IP version 6 is because the IP version 4 probably we might it might get exhausted in the near future. We have to migrate to the the more the more IP addresses and so on. So in that for that case, we have to implement the IP version 6. For now, it's fine. We can able to run that with an IP version 4. It should not be a big issue, right? That is one thing. So that is how the communication from the IoT device will be established through the gateway. Okay, in the gateway, they will be running the proxy. Okay, and then this proxy, the CoAP, that is running from the IoT device to the gateway, right? After this, to the cloud, either we have to use HTTP or MQTT. So this is the recommended one. From the field device to the network gateway, we have to run CoAP. Okay, this is very lightweight, right? So this is the use case where we have a very smaller the bandwidth across the building or else across the facility, right? For that, the communication from the IoT to the gateway, that is the main the router. We always use the CoAP one. From the router, we can able to use the other protocols. This is a very secured one, right? So this is how it is. Okay, and that is what the slide is telling. Okay, the CoAP rarely operates in the isolation. Okay, it relies on the edge gateways acting as a proxy to translate the lightweight edge traffic to the standard web traffic for the cloud integration. Okay, and that is what I was explaining. From the zone 1 to zone 2, it is all about the CoAP we are running, and from the gateway, that is edge, perimeter edge to the cloud, usually we use the standard, that is HTTP or MQTT. Either one we can able to use it. Okay, coming to the let's understand the protocol stack. So if you observe, this is similar to the OSI model only, right? So the OSI model have the 7 layers. It is similar to that only, but only the the minor changes. Okay. So what the protocol stack look like? Okay, one is network layer. Okay, the transport, the message layer, and the request and the application one. Okay, let's see what exactly these are in the depth. Okay, the first one, application layer. In the application layer, it is all about the IoT endpoint sending the data and the receiving the data, right? So that is what the IoT here it's a sensor data. Okay, the commands, the device services, and so on. So here endpoints we can able to use for the temperature, the humidity, energy usage, the device status, and so on. How this acts as we understand, this is similar to the HTTP only, but this protocol is lightweight and works on the UDP, right? So here also, and we use REST APIs. Okay, when we say REST APIs, it is all about request and the send response layer. Okay, similar to the HTTP. Here also we have the the get, the post, and put and delete. So when we say the get, it is all about retrieval of the data. Okay, we are asking the server to provide the some information to us, and when it comes to the post, it is all about the sending or the creating. Okay, And when it comes to the put, it is updating the data in the server side. And the delete is obviously it is an removal of the data, certain data. Okay. Now, just to give you an example how it looks in the real time, if you see here, the request, that is the get, this is specific, the details which we will be sending. And so the response will be, the server will send the response telling that, okay, the content and the temperature details. Okay. So this is how it will be. Let's, yeah. So this is how it is similar to the HTTP. That is what I'm trying to say. Okay. Now coming to the other part, that is the messaging layer, right? So let's go in the depth how the client and the server, they exchange the data. So they exchange in the so basically the client will send the response, this con get, okay, that is the request which will be sending to the server. So this is like confirmable, the message that requires the acknowledgement message. So acknowledgement message is sent like telling, so we have received the response and the server is sending the response back. That is the acknowledgement. So basically the server is acknowledging the request which the client is telling. Okay. And this is one type. And the second type what we have is non-confirmable message. So this will take this is reliable, and it compared to this the the confirmable message, right? It is slower, because so we need to get the acknowledgement response also, right? The reliable, but it is very much reliable. But in this the confirmable message type, this is like fire and forget, that's it. So we don't have to, I mean, the system will not get any acknowledgement message. Okay, that is one thing. And the REST is a reset message. Okay, if something, the context is missing or the failure, then the system tries to get the information again in that the context. So this will help us. Okay. Now, why this is very much faster? Because the CoAP abundance, like it will not be using any heavy handshake as it is used in the TCP. Okay, when the TCP, it is a reliable. Okay, the number of handshakes between the client and the server will be more, so that the packets sending and receiving, it will reach the respective destination without getting dropped. So that is the main objective of using the TCP, okay, at the message layer. But here we use UDP. UDP is like even though the packets drops during the transit, the system will not try to retrieve back. Okay, so that is the major differences. Okay, that is what I was telling. In the transport layer, right? It uses UDP instead of TCP. Okay, right. The advantage here is the low overhead, the faster communication that help us in reducing the energy consumption, right? And this is ideal for the low bandwidth networks. So we have to keep in mind when to use which the protocols. Okay, and the typical networks includes the IP version 6 and the 6 LOWPAN, right? This is the IP version 6 over low power wireless personal area network. So if you are using like Wi-Fi, correct, so we can able to use the IP version 6 low power wireless personal area network. Okay, this is also open standard. If you see, IETF open standards, right? So we can able to find this one thing. Okay, again, this is also for the low power and resource constrained devices. Okay, the primarily for the IoTs. And coming to the IEEE reference, we can take the 802.151.4. This is what the IEEE standard for this. Okay. And again, so this one, LORAWAN, that is low power, long range wireless networks. This, for example, if we have the bigger, the campus, correct? And we are using the wireless to communicate to the IoT devices. How do we do that? So either we use this specific the protocol, that is long range wireless area network, so that these devices can be directly talk to the outside network, and from there we can able to talk to the servers. Okay. And yeah, so whenever we use this, again, this adds up to our advantage of saving the battery powered the IoT's energy. Okay, that is the important use case for us. Now let's go little depth, okay, in terms of the packet level. Okay, so if you see here the packets, again, this has the header. This header is of the four bytes tightly packed one. Okay, so in that we have the what header will carry is header will carry the revision, the type, the token length, the code. If we are sending any message ID, then we usually add that in the header. Okay, and so the next part is the token one. Okay, so token basically it will be 0 to 8 bytes. Okay, use it for the matching response to the requesters, right? And the third part is the optional, but we can able to provide the URI, okay, or else the content, the format, and so on. So if we are specifying any one of these parameters, it will be embedded in these options. Okay, and yeah, the last part here is it is the payload. This is the actual sensor data. Okay, we saw earlier, right? The sensor data will be in the JSON, right? So this is what the actual data it will be sending through the payloads. Okay. Yeah. So this is all about the structure of the packet, the CoAP message packet. Okay. Now, coming to the communication flow, right? How the communication will happen. So here again, let's take an example of the smart meters. Okay. In this scenario, the smart meter is trying to send an energy consumption data. Okay. To the IoT server, because the usually CoAP is only implemented from the client, that is IoT device, to the gateway, not directly to the cloud system, right? So this is where we are mentioning the client. The client is the smart meters. Client is the smart meter, and this is the gateway that could be a router. Okay. Now the client, in the first step, what the smart meter will do is, if you see the con, we have seen the type of messages, right? Con means we are expecting the acknowledgement from the server. Okay, that is the IoT gateway. So what we are trying to do is we are trying to post the data. What is the data? The meter ID, the energy usage. This is the energy usage. We are trying to send the data. Okay, so this is what we have to provide the gateway, gateway, and certain details. That is URIs. Once it has been successfully reached the server, what server will be doing is it will send back the acknowledgement. Okay, so if we are using non-con, then the acknowledgement will not be sent back to the client. Okay, but here we are requesting an con, right? So when we request the con post, in that case, we are telling the server to send back the acknowledgement one. Okay, so that makes the complete communication reliable, data transmission and the acknowledgement. Okay, So here only the two data. If you see, only the two ultra wide UDP packets are used. One is for the post, other one is for the acknowledgement. Okay. So these two will help us in understanding the communication one. Okay. So again, this is another example, just to give you an the comparison between the so let's take in a comparison. Okay, the HTTP and this CoAP, the protocol. What exactly it is? Why it is efficient compared to the other one? So if you see the number of handshakes, right? The temperature. So too many times it has to go, then acknowledgement, again go back, go back, go back, go back. So basically, um, so instead of doing that, what we will do is like just sending one the request, that is the get, asking the server to send the specific details, and so what server will be sending, it will keep on sending back the details at an regular interval of time. Okay. So basically, if you see again here, you might be comparing that with an pub sub model, correct? Similarly, we can able to do the same configuration here, right? Once we ask for a certain details, the client is asking for a certain details from the server. Server will receive that, and it will keep the data coming in instead of we sending the data again because it isn't REST API, correct? And we got to know that it isn't stateless. Every time if you want to do the communication or like established and communication, it has to be new connections, right? It is not that efficient. So instead of that, we can able to do the configuration such a way that if the client asks for certain details from the server, so that will be fetched, and the server will be keep sending the data as required. Okay, that eliminates continuous polling. Okay, and when we eliminate the continuous polling, that means we are saving the bandwidth one. Okay. Now, again, so the security part is very important one, right? Let's see how we can able to secure the communication one. Okay. Again, here it's all about the encryption. Okay. So here you can able to see it supports AES, SHA, and ECC. Okay. So the security features, it is not only limited to only the data transfer encryption, right? So it is like an the encryption is must for the data in transit as well as data at rest. Okay, and AES is one of the the mostly adopted algorithm, that is AES stand for an advanced encryption standards. What it will be doing is it uses a symmetric key algorithm. Okay, so that utilizes for the encryption of the large amount of data at a high speed. Okay, so whenever we are sending in data, right, at transit, so basically we use that one thing. And SHA is like secure hash algorithm. Okay, so this will be this algorithm that generates an unique but fixed size the value that will be an hash value. Okay, that is used for the encryption. Okay, and ECC is an elliptic curve cryptography, so modern public key system, right? This is one thing. And yeah, so basically what I'm trying to say is, so the CoAP algorithm, I mean the protocol, that maintains robust security without relying on heavy TCP based TLS. Okay, that is what, because we are using UDP here, right? For that reason. Okay, and it uses the data transport layer security, DTLS. It is the very famous one. Okay, to provide the encryption, authentication, and safeguard the message integrity. Okay, over the UDP. Right, that is one thing. Now let's understand. Let's implement this in the real world. Okay, So in the real world, in the here also we are considering the modern grid. Okay, the CoAP. So that operates exclusively at the edge. When I say exclusively at the edge, so this will be utilized only from the edge to the gateway only. Okay, that is where I am clearly mentioning that this exclusively at the edge. Okay, the pushing data to the local gateways, while from the from the local gateway, the all the heavy lifting, that is the most of the the batch data, the collected data, right? The batch means the collected data. It will be transmitted to the cloud platform by using either HTTP or MQTT. So this is needed because the CoAP is not capable of handling the higher uh, the packets, and it is not that reliable for the internet transits. Okay, for that reason, we use HTTP or MQTT to push the data from the gateway to the cloud. Okay, that is the main important difference. Okay, yeah, let's talk about the architectural trade-off. Okay, the advantage and the disadvantage part. When we talk about the advantage, right? So from these different slides, we got to know that this is extremely lightweight and it is very much suitable for the low power device because it works on the UDP one, right? One thing. So UDP reduces the multiple handshakes, okay, and it reduces the latency. For that reason, it is most preferably used in the IoT implementation, okay, and also it supports the RESTful. And when I say that, it also ensures that we can easily able to integrate with the web applications, right? And natively it supports PubSub. And in one of the example I said, right, instead of we sending the multiple requests to the server, once we send the request to the server, and the server will keep on sending the updated the data back to our the client. Okay, so that we can able to reduce the more requests to the client. Okay, and coming to the security, the robust DTLS, that is datagram transport layer security, is what we will be using in that means even though we are using the UDP, right, the data is encrypted in the transit by using the DTLS security. Okay, this is one of the point. And the second point is the limitations one, right? In the limitations, so again, we are using UDP, right? So UDP is not that much reliable. Okay, why we are using, even though that is not reliable, why we are using that in the CoAP is because to achieve the faster, to achieve the less latency, right? For that purpose, we are using this UDP one. Okay, in the application layer. And if certain the packet get dropped, okay, so we cannot able to retrieve that, and that is one of the major drawback. We have to again send the back packet if we are not enabled any acknowledgement, right? In that case, again, we have to check and we have to send back the data. Sometimes we might miss that part. Okay, and again, other point is strict limitation on the payload sizes, right? So as this is a lightweight protocol, the payload cannot be the more right, it has to be very much smaller one. Okay, and the last but critical limitation is we cannot use this protocol to transfer the data to the cloud. Okay, we have to implement either HTTP or else MQTT for the communication from the cloud to the edge, that is IoT gateway. This protocol will not be able to send that. So that is one of the limitations. Okay, so if we are choosing this, we have to implement the HTTP or MQTT. So two configurations we have to do. That is one of the limitations what we are having. Okay, and again, just to summarize everything on this. So again, we have a three important communication protocols. Okay, one is CoAP, Constrained Application Protocols, and MQTT and HTTP. Okay, whenever you get an the question in the exam, right, to define all these three important communication protocols, you have to make sure that you define in the such a format. You have to differentiate three in terms of transport and architecture. Okay, CoAP always works on UDP and the rest, and the MQTT it's TCP, but the publisher and the subscriber model, and the HTTP it is an TCP and REST. Okay, and coming to the overheads, extremely low for the CoAP, and okay, the low it is for the MQTT, and the high overhead for the HTTP one. Okay, so when it comes to the use cases, right? So CoAP is widely adopted in the IoT sensors. Okay, and MQTT is where we need a continuous message system from the IoT device directly to the other consumers, like the cloud, and we could able to send those data directly to the other analytical the platform, right? In that case, we always use the MQTT one. Okay, and HTTP is required where we are using the standard web services and the enterprise API. Okay, so this is all about three important the communication protocols what we have to study as per the your syllabus, right? Okay, so yeah, so make sure that you understand. So CoAP is where implemented where we have the low bandwidth, and if we want to have the very reliable communication, choose MQTT, and the traditional web infrastructure we are having, then choose the HTTP one. Okay, so this is all about the protocols. So in this session, what and all we covered? Three main the protocols, right? And yeah, so almost everything is completed. And this is not only limited to these three the protocols in the industry. Okay, there are a lot of other protocols, and if anyone has interested in looking into that, right, so you can able to research on that and able to get more insights. Okay, I think I'm good from my part. So I am concluding the session.